Hello students and welcome to the lecture. So students, as you can see that basically in this lecture we are going to start the discussion over the universe. Okay, and this is going to be our part 1. In this lecture we will talk about the universe. Like we will start with the universe as an introduction, galaxy, then classification of galaxies, our own galaxy Milky Way, constellations, Ursa Major constellation, Ursa Minor constellation, Orion constellation or Hunter constellation, Scorpion constellation, Pleiades constellation, galaxy and constellation, stars, pole star. The stars are not permanent. Birth and evolution of a star, formation of a proto-star, formation of a star from proto-star, final stages of a star's life. Okay, so this is all that we are going to discuss in this particular lecture. But as usual, before starting this actual lecture, we are going to have the small disclaimer over here that we are required to understood before we proceed further. So a disclaimer goes like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the image. So let's have a talk about the universe. So first, let us understood that what do we mean by the universe in reality. So the vast surrounding space is called universe. The universe includes everything that exists in this world, the most distant stars, planets, satellites, as well as our own Earth and all the objects. So if we talk about universe, then there is no standard criteria to define that whether this thing is a part of universe or not. Universe is actually the vastness thing that includes everything that exists. The most distant stars, the planets, satellites, as well as our own Earth and all the objects on it are the part of the universe, including you and me also. Nobody knows how big the universe is or whether it has any limit. So far, whatever studied we have done, so far, whatever we try to discover about the universe, then based on this data, we have the two scenarios. First, we think that the universe is limitless because we don't know how big it is. Second, maybe there is a limit for universe, but we are not able to catch that limit. So these two scenarios exist. So no one knows how big is universe and no one knows is there any limit for the universe. In order to study the constitution of this universe, we have to first discuss the objects like galaxies, stars, planets, and satellites, etc. Like how the universe got constituted. If we go by this, then we have to discuss the objects like this, the galaxies, the stars, the planets, and the satellite, etc. Because everything is the part of universe. The units of measuring distances in the universe is the light year. 1 light year is a distance traveled by light in 1 year. Okay, and it is nearly about 9.46 into 10 power 15 meter. That is equal to 9.46 into 10 power 12 kilometers. Okay, so this is what we call the light year in the terms of kilometer, and this is what we call light year in the terms of meter. Okay, now let's have a discussion over the galaxy. So galaxy is actually the vast collection of billions of stars, dust and hydrogen gas that is isolated in space from the similar systems. Actually, the galaxies are the building blocks of this universe. There are about 100 billion galaxies, or we could say 10 power 11 galaxies in the universe, and each galaxy has on average 100 billion stars. That means 10 power 11 stars. So the total number of stars in the universe is nearly about 10 power 22. There are two important galaxies in the universe. First, the Milky Way galaxy, and second is Andromeda galaxy. Okay, so these are the two galaxies we are known to in this particular universe. First is the Milky Way, second is the Andromeda. Okay, and why we are saying that these are two important galaxies? Because first reason is we have the limited knowledge about the universe. So that's why we often consider the Milky Way and Andromeda as the important galaxies. Second, that these galaxies, one of them we live in, means Milky Way galaxy. So that's why it is important for us. So these are the two reasons why these galaxies become important. The first is we only have a limited knowledge of universe. So far we have done our exploration till these galaxies only. Second, because in one of them, Milky Way, we live in, so that's why it's become important for us to know about. Our own sun and its family of planets. It means the solar system, including the sun and the 8 planets. They all are belong to the Milky Way galaxy. And in the India, we call the Milky Way as Akash Ganga. Okay. So remember, the Akash Ganga and the Milky Way, the both are same. In English, we called it as a Milky Way. In Hindi or in India, we call it as Akash Ganga. So do not get confused by seeing these two names. They both are the same. Milky Way is a galaxy which comprises of billions of stars, the hydrogen gas, and dust. And if we talk about the diameter, suppose this is the Milky Way galaxy and it is as a circle. Let's assume it as a circle. Okay. So if we talk about the diameter of this particular Milky Way, then the diameter is nearly about 1 lakh light year. Okay. And the solar system, that's the sun and the group of 8 planets, this is the part of this Milky Way galaxy. Okay. The galaxies were formed by the collapse, shrinking of vast overdense clouds of hydrogen gas and dust. Now let's have a talk over the classification of galaxies. So galaxies have many different shapes and sizes. They are not in the uniform shape, they are not having the same shape. They differs in the shape and their sizes. The galaxies are usually classified on the basis of their shape. So whenever we have to classify the galaxies, so what criteria we choose to do this classification? Their shape. The most common shape of galaxies are actually the spiral shape, elliptical shape, and irregular shape. So these three are the most common, or you can say dominating shapes of the galaxy. Some of the brightest galaxies are actually the elliptical galaxies, but some of the biggest galaxies are actually the spiral galaxies. So here you can say this shape is actually the spiral shape. This shape is actually the elliptical shape. This shape is the irregular shape, means that it is not having any particular shape. So going by this, remember, the largest galaxies are generally of the spiral shape, and the brightest galaxies are generally of the elliptical shape. Got it? So because the Milky Way is actually in the spiral shape, so Milky Way is one of the biggest galaxies existing in this particular universe. Now let's move ahead. Now let's have a discussion over our own galaxy, Milky Way. So Milky Way is our own galaxy. It is spiral type of galaxy, as I've shown you. Like in this picture also, you can look at it. So this is the spiral shape, right? So this is one of the biggest galaxy existed in this universe. We live on the outer edge of this galaxy, means somewhere here or somewhere here. I don't know the exact location, but outer edges means we are here. The diameter of this galaxy is about 1 lakh light year, as I have shown you. Like suppose if this is a circle, so the diameter or the width, it is about 1 lakh light year for this particular galaxy. The galaxy is slowly rotating. Here you can see that if you look at this edges, what you will find? You will find that it is actually rotating and it is slowly rotating. The view of the Milky Way galaxy looks like a disk of stars. The stars are not uniformly distributed in the plane of disk, but are arranged in spiral arms that emerging from the nucleus of the galaxy. Okay. Now let's move ahead. The stars in the Milky Way galaxy are slowly rotating about its centers. So here you can see. Okay. These stars are actually slowly rotating about the center of this particular Milky Way. Okay. That's why it forms the spiral shape. The disk of stars is quite thick at the center, representing a relatively high concentration of the stars at the center. So if you look at this picture carefully and if you look at the center, what you're getting? That this is the brightest part, right? Our sun and its planets located on one side of the disk, like structure at a distance about 30,000 light years from the central region of galaxy. Thus, the sun is far away from the center of the Milky Way galaxy because it is nearly about this side. So you can say it is actually far away from the center. From our position in the galaxy, we could see it other armed the Milky Way as a bond of stars faintly whiting the sky from north to south on a dark night. Now, what are the constellations? Let's have a look on them. So, basically the stars which appear in the form of close groups and form a recognizable shapes and patterns, these we call the constellation. So, in a you can say normal terms, we could say the constellations is actually the group of stars that resembles or appears while forming some shapes and patterns that could be recognized easily. Our ancestors named these stars or constellations after the objects which they seem to resemble. So you can say, prior to us, the humans that were living there, our ancestors, they observed these shapes and whatever they resemble that this is forming, they named after the star group or constellations like that. The Indian name for the constellation is Nakshas. About 88 constellations are known. Each constellation has been assigned a name signifying an animal, a human being, or some other object which it appears to resemble. Okay, so if we talk about the shape, patterns, and sizes that we could see in these constellations, then sometimes they are signifying as an animal, sometimes as a human being, or sometimes any other object. Okay, this is not having any fixed kind of shape and size and pattern you can see. Some of the important constellations are first is Ursa Major, that is also known as a Great Bear. In Hindi, we call it as a Saptarishi. Ursa Minor or Little Bear. In Hindi, we call it as a Lagu Saptarishi or Dhruva Matsya. Orion Hunter, we call it as Vayat or Mirka. Scorpion, which we call as Vrishika also. Pleiades, Krutika. Cassiopeia, Surasmita. Okay. Now let's have a first Ursa Major constellation. Like what do you mean by this? Let's understand. So the Indian name of Ursa Major constellation or Great Bear constellation is actually the SATHEE-RRB. The arrangement of stars of Ursa Major constellation is shown in the figure. Here you can see 1, 2, 3, 4, 5, 6, 7. Okay. So this is the Ursa Major constellation, also what we call as a SATHEE-RRB. The Ursa Major constellation or Great Bear constellation consists of 7 bright stars arranged in a pattern resembling somewhat a big bear. The Ursa Major constellation could be seen clearly in April in summer season in the northern part of the sky at night. So we could say, if we talk about the northern part and we look the sky at night during the summer season in the month of April, then we could easily recognize the Ursa Major constellation because it could be seen clearly. Thus, the Great Bear is often called the summer constellation. Why? Because it is clearly visible during the summer nights, mainly in the month of April. Now, the Ursa Minor constellation. It is also known as Little Bear constellation, as we know. The Ursa Minor constellation is also a close group of 7 stars. Here you can see 1, 2, 3, 4, 5, 6, 7. Or we could also reverse it 1, 2, 3, 4, 5, 6, 7. Okay. So this is also a group of 7 stars. The stars in the Ursa Minor less bright than those of the Ursa Major. So if even you are not able to recognize the pattern, and if you are seeing the group of 7 stars and you try to classify the Ursa Major and Ursa Minor, then how you could do it? Just remember that the stars in Ursa Minor are less bright, whereas the stars in the Ursa Major are more bright. Okay. At the end of the tail of Ursa Minor is very important star of average brightness, that is what we call as pole star. Okay. So here you can say we start from here 1, 2, 3, 4, 5, 6, and 7. So this 7, the tail, okay, that tail will be the pole star. The pole star appears to be stationary in the sky and all other star groups appear to revolving around it. So we could say that suppose this is a pole star. So these stars will revolve around it. But the pole star will appear as a stationary star. That will not change the position. The Ursa Minor constellations could be seen in the northern part of the sky in July during the summer season. Okay. The Indian name that we use for the Ursa Minor constellation is Laghu Saptarishi or Dhruva Matsya. Then Orion constellation or Hunter constellation. The arrangement of stars in the Orion constellation is shown in the figure. So Orion is actually means the hunter. The Orion constellation is visible during the winter season. Remember this, that the Orion is mainly visible during the winter season. The Indian name of Orion constellation is Vayat or Mirka. Thereafter, Scorpion constellation. The arrangement of stars in the Scorpion constellation is shown in the figure. Here you can see it. The Scorpion constellation is usually visible in the summer season. The Indian name that we use to represent the Scorpion constellation is Virashika. Here you can see Virashika. . Then Pleiades constellation. The Pleiades constellation does not have any particular arrangement of stars which could be compared to different shape. So here you can see that rest of the other constellation were actually the group and they could be resembled as particular shape and pattern. Pleiades is that constellation which is actually a group of stars, but not you can say showing any particular or definite shape. Okay. The Pleiades constellation looks like a cluster of twinkling gems in the night sky. Here you can see that it is not having any definite shape. It is just appear as a twinkling gems in the night sky. The Pleiades constellation is visible in winter season. Okay, like you can say in the winter season, you could easily see it. The Indian name of Pleiades constellation that we use is Krutika. Okay. Now the galaxy and constellation. We know that galaxy consists of stars and a constellation also consists of stars. So let us find out the difference between the two. The difference between a galaxy and the constellation. First is the first difference is that a galaxy is collection of billions of stars, whereas a constellation is the collection of only a very few stars. The second difference is that a galaxy does not form a definite pattern which resembles the shape of an animal or a human being, but a constellation appears to resemble an animal or human being in its shape. The third difference is that there are billions of galaxies in the universe, but as per best of our knowledge, we are only known to 88 constellations at present. Maybe we are not saying that these are the only, maybe there are more. But so far, as best of our knowledge, we could only resemble 88 constellations. We could not go beyond it. Now the stars. What do we mean by the stars? Let's have a look on this. So stars actually and heavenly bodies like the sun, and these are extremely hot and having their own light. So it means that they are the luminous objects. Stars are made up of vast clouds of hydrogen gas, 70%, some helium gas, 28%, and the rest is dust. Okay, so we could say everything is 100%. So 70% is hydrogen gas, 28% is helium, and remaining 2% is the dust. Because if you add 70, 28, that will be a 98%. Okay. In all the stars, hydrogen atoms actually continuously being converted into helium atom, like the nuclear fusion. And the large amount of nuclear energy in the form of heat and the light is released during this process. It is this light which makes a star shine. So why the star is actually shining? Because the hydrogen atoms continuously converting into the helium atom, nuclear fusion, that is producing the light as well as the heat energy. Thus, a star is the hydrogen nuclear energy furnace so big that it holds together by itself. So there are billions and billions of stars in the sky, but only about 2000 stars could be seen with the naked eye on a clear moonless night. So from Earth, if we use our best eyes still, we could only see 2000 stars. We could not see beyond it. All the stars are very big in size. They appear small because they are very far off from us. So actually, in reality, they are very big, but we are seeing them just as a dot because they are very far from us. The stars twinkle at night, that is, the intensity of their light appears to increase and decrease continuously. And because of this increasing and decreasing of the intensity of light, they are appearing to be twinkled. The stars classified according to their physical characteristics like size, color, brightness, and temperature. So in order to classify the stars, we could conclude these things like the size, color, brightness, and temperature. Now, what is the pole star? The star which lies immediately above the Earth's north pole and around which all over stars seem to revolve is that we call as the pole star. The Indian name we use for pole star is actually the Dhruva Tara. The pole star appears to be stationary in the sky and does not change its position at all. It has been observed that all the stars except the pole star appear to move from east to west. How? Let us get the explanation of this. It has been found that the Earth itself rotating on the axis from west to east direction, due to which the stars appear to move in the opposite direction from east to west. Thus, the apparent motion of stars in the sky is due to the rotation of the Earth on its axis. The pole star appears to be stationary and does not change its position with the time because it lies on the axis of rotation of Earth, which is fixed and does not change with time. So that's why it appears as a fixed, because it is fixing on the Earth's north pole, and the Earth's north pole is not changing its position with time. So that's why it is also appearing as a stationary one. And others are not, so that's why they appears revolving around the Earth in the east to west direction. The stars are not permanent. How? Let's see. So the stars are born, mature, grow old, and finally die. The stars do not last forever. They also having a lifespan, and once this lifespan is over, they got finished. The physical characteristics of a star like size, brightness, color, and temperature also change with time. The changes which take place in the star actually take a very, very long time, which could be of millions of years. On the other hand, our lifespan is comparatively very small, say 75 or 80 years only. So that's why the stars having millions of years lifespan. So it is hard that if we see any star dying in a lifespan, because in comparison of millions of years, only 75 and 80 years is you can say not even the proper decimal. Okay, so there is no need to compare. So the stars appear to be permanent for us because in their lifespan and in our lifespan, there is a huge difference. Our universe contains millions and millions of stars which belong to the different age groups. Some stars quite young, some stars are of middle age like our sun, whereas still other stars are in the final stage of their life, being on the verge of death. So now let's see what is the process of birth and evolution of a star. The raw material for the formation of star is mainly hydrogen gas and some of helium gas. The life cycle of a star begins with the gathering of hydrogen gas and helium gas present in the galaxy to form dense clouds of these gases. The stars are then formed by the gravitational collapse of these over-dense clouds of gases in the galaxy. The first step in the formation of a star from gases is the proto-star. Now, how the formation of proto-star takes place, let's see. In the beginning, the gases in the galaxies were mainly hydrogen with some helium. But they were at very low temperature of about minus 170 degrees Celsius. Since the gases were very cold, they formed very dense clouds in the galaxy. Since the gas clouds was very large, so the gravitational pull between the various gas molecules was quite large also. So due to the large gravitational force, the gas cloud started contracting as a whole. This is shown in a figure. Here you can see huge cloud of hydrogen is actually contracting with each other. Ultimately, the gases compressed so much that they formed a highly condensed object, what we call as a proto-star. Here you can see. So these were the gases that were contracting, and then it is the circle they had made. Thus, a proto-star is a highly condensed cloud of gases, mainly hydrogen and some helium, formed by the gravitational contraction of gases present in the galaxy. A proto-star looks like a huge drag ball of gas. The formation of protostar is only a stage in the formation of complete star. A protostar does not emit light at all. Now, what is the process of formation of a star from the protostar? Let's have a look on this also. So the protostar is actually the highly dense gaseous mass which continuously to contract further or shrink further due to the tremendous gravitational force. As the protostar begins to contract further, the hydrogen atoms present in gas cloud collide with one another more frequently. These collision of hydrogen atoms raise the temperature of protostar more and more, and the process of contraction of protostar continues for about 1,000,000 years, during which the inner temperature protostars increasing from mere minus 173 degrees Celsius in the beginning to about 10 power 7 degrees Celsius. And at this highly, extremely, or you can say extremely high temperature, nuclear fusion reactions of hydrogen stars taking place. In this process, 4 small hydrogen nuclei fuse to produce a bigger helium nucleus, and tremendously amount of energy is produced in the form of heat and light. That is like 4-1H fusion equals to 4He plus tremendous energy. Now the energy produced during fusion of hydrogen to form helium makes a protostar glow, and it becomes a star like figure C. The stars do not collapse at all. In star, two types of forces acting continuously. Thus, the star is now in equilibrium under the action of two opposing forces, the gravitational force, which is trying to compress the gases, and the second form is internal pressure due to the nuclear energy, that is trying to stop the gaseous matter from collapsing. If internal pressure not built up within the star, a star would have collapsed within less than an hour or half an hour. In a mature star, the pressure forces from within the star balance the gravitational force from outside. This balance could continue for millions of years. Now, what is the final stages of a star's life? In the first part of the final stage of its life, a star enters the red giant phase, where it becomes a red giant star. After that, depending on its mass, the red giant stars could die out by becoming a white dwarf star or by exploding as a supernova star, which ultimately ends in the formation of neutron star and black hole. So first is the red giant phase. Initially, the stars contain mainly hydrogen. With the passage of time, hydrogen gets converted into helium from the center outwards. Now, when all the hydrogen present in the core of stars get converted into helium, then the fusion reaction in the core would stop. So ultimately, the matter in the core of the star would consist only of helium. Due to the stoppage of fusion reaction, the pressure inside the core of the star would diminish the core that would begin to shrink under its own gravity. In the outer shell or envelope of the star, however, some hydrogen still remains. The fusion reactions would continue to liberate energy but with much reduced intensity. Due to all these changes, the overall equilibrium in the star is upset. And in order to readjust it, the star has to expand considerably in its exterior region or the outer region, while its core shrinks because of the dominance of gravitational forces. Due to the large expansion of the outer shell, the star becomes very big. It becomes a red giant. And its color changes to red. Like here you can see. This is a red giant, this is sun. Here you can see how big it is. At this stage, the star enters the red giant phase and it is said to become a red giant star. Thus, in the change from a normal star to the red giant star, the core of the star shrinks where as the outer shell or envelope expands greatly. It is called red giant star because it is red in color and giant in size. A star spends a comparatively short time in the red giant phase because it is quite unstable in that state. So when a star reaches the red giant phase, then its future depends on its initial mass. Two cases could be happen here. If the initial mass of the star is comparable to that of the sun, then the red giant star loses its expansion of outer shell and core shrinks to form a white dwarf, which ultimately dies out as a dense lump of matter into space. Second, if the initial mass of the star is much more than of the sun, then the red giant star formed from its explosion and the form of a supernova star, and core of its exploding supernova star could shrink to form a neutron star or a black hole. So with this, we have finished this part. It is requested to all of you kindly revise the facts and figures at all we have discussed in this lecture and get ready for another lecture. With this note, let's end this lecture and thank you.